Hello everyone, welcome to another problem session. So today we have this interesting problem um, from 2020 JEE Advanced Physics. Okay, um, let's read this problem. So you have both sides are open tube. This is open tube, and then originally you had just one fluid. That this fluid was of that you had from here all these fluids. The green fluid is the only fluid there, but was not uneven level. It was somewhere in the middle. Let me use a ruler to draw it out. So it will be, let me see if I can draw this out in a nice way. Yeah. Oh. So I'm using on a screen, and it's kind of hard to draw. So originally it was the even level, and so this used to be green over here. This used to be green over here. Same fluid, but now this fluid is now all the oil. Okay, so a volume here, volume pushed down must be this volume on this side pushed up. Pushed up on the other end, right? Fluid is not going to go anywhere. This volume of the green must equal to this volume of the black. And this cross section is same as this cross section. That will mean the height here, and if you were to extend this on the other side, must be equal to these two heights must be equal to. So let's call it D and D. There's equal to, and let's call this H. So H is the fluid, the oil that you have poured down, okay, on one side. So that's the condition. Originally this level, this common level, originally this level, this was supposed to be, let's call this H0, when they were all the same both sides and just water was there. That was 0.29 meter. Okay. So what's the principle that we should use to figure out the ratio of these heights H1 to H2? It seems like a complicated problem. However, the problem is extremely simple if you think about it from the principle point of view. So if you look at from here to here, this is one fluid, right? So if I look at this lowest level of that fluid, and lowest level, let's call that level, let's call this A, and this middle level, this, let's call that B, and this level, on this side I'm going to call it B, and this I'm going to B prime. This side I'm going to call A, and this going to be A prime. This point A prime, and this point A. This point I'm going to call B, and this point is B prime. And this will be like a C, and this is going to be C prime. And then you have another level is this. this point kind of D, but this kind of D prime. Now it turns out that if you stay in the same liquid, the lowest liquid, so here's the principle. Principle will be lowest liquid which is H2O here, is this green liquid is the lowest liquid. Lowest liquid. In that liquid, any point, any level you pick on the two end, the pressure at say L and L prime, they will be equal. Same level, same pressure. So of course this point is arbitrary, so it doesn't help us, even this principle is true. Okay, so the best place is A and A prime. If you equate the pressures of these two, you will get a condition. So PA equals to PA prime. What does it become? PA is atmospheric pressure plus the pressure of this fluid, this much fluid above it, and this is going to be atmospheric pressure P0 plus rho of oil G and this H. That's on this side. On this side is atmospheric pressure comes all the way down here, not just D and D prime, but all the way to C prime, and then this much water. Okay, so P0 plus rho water G, and then this is 2D, 2 times D. If you look at okay, so what's the D? You know, you have to have some aspect of D. So how is D related to H2 and H1 and things like that. So if you have a D is H2 minus 2D must be equal to H1 minus H. So this is so the D is not completely independent of things, it's just related to other things. Let's carry on with this. P0 cancels out, then this is left, then G will cancel out, and so, and this is 800 and 1000, not 2, the G will cancel out. So this 800 over 1000 times H equals to 2 times D. So D actually is, we know how much D is. So D is equal to 0.8 and H was 0.1 over 2 is 0.4 times 0.1 is 0.04. So that the D is 0.04, so 0.04 meter, 0.04 meters. Actually this thing probably should be done in centimeters. Okay, so the D found out, but H1 minus H gets this level. Start from D and start from C prime, H2 minus 2D, H2 minus 2D. So that's one condition between H2 and H1. Okay. And the other condition would be how to get to the H0, this H0. So H2 minus D is same as H0. So from here I can get what H2 is. H2 is D plus H0, and D we just found was 0.04 plus 0.29 is 0.33 meter, and from here H1 will simply be H plus H2 minus 2D. So H is 0.1 plus H2 is 0.29 minus 2 times 0.04. Something's not right, looks like. Okay, so I found my mistake before I got too far away. Is for H2 I was putting at 0, so I should put 0.33. That should be 0.33. So I got 0.43 minus 0.08 is 0.53 meter. Okay, that's good. So H1 over H2 should equal 0.35. I'm making all these stupid errors. 0.35 over 0.33 equals 35 over 33. This is correct. I think there's another way to do it with less error. Let me do it that way also. So rather than use this, let's use this column itself. So if I go H1 and take away the entire H and add D, take out the entire HD must be equal to H0. So here I know everything, I don't have to H2. So H1 is going to be H minus D plus H0. So H is 0.1 minus 0.4 plus 0.29. So this is also 0.39. Take away 0.4 is 0.35 meter. So this is the same as that. Okay. All right. So what was the main principle? Main principle was this: like, if I'm in the lowest fluid, if I take a point here and on the same level I go on the other side, pressure will be same. That's the main. Now it won't work for any other level. Like if I take a B here and I say B prime, are the pressures the same? No, they're not the same. First of all, they're in two different liquids. Okay, how about anywhere here and then over here? The pressure the same? Of course not. You see there's atmospheric pressure here, and it's atmospheric pressure plus this much fluid. Only when you get out over here to here, you can see this now is atmosphere all above. So this same fluid. So that pressure there is the same. So as long as you have same fluid, you can see the atmosphere is the same. The pressure there is same, but when you have like this situation like that, then the pressure is not same till you get to this point, and the pressure at all of this same level, same fluid, pressure will be same. So that's the main principle here, and everything else is just using geometry. Another thing that you should be aware that we used the cross section here was same, and the tube had the same thickness on both sides. Now if one side was narrow, another side was wide, you'll have to use this volume principle. The volume same on the two sides to relate to the heights. And I've seen problems where people were tricked into thinking in terms of heights. Well, they should have been thinking in terms of the volume. Okay. All right. This is enough for now. I'll talk to you in another video. Bye.